Space, the final frontier, it stretches out before us, vast and unending, a canvas of infinite possibilities and untold mysteries. The cosmos beckons us to explore, to seek out new worlds and new civilizations, to boldly go where no one has gone before. It holds mysteries that capture our imagination, drawing us into its depths with the promise of discovery. Each star, each planet, each distant galaxy is a story waiting to be told, a secret waiting to be uncovered. One such mystery is the possibility of planets like Miller's planet from the movie Interstellar, a world that challenges our understanding of what a planet can be, a place where the rules of nature are rewritten, a world covered entirely in water. It orbits a giant black hole named Gargantua. The gravitational forces at play are immense, creating tidal waves that dwarf anything we've ever seen on Earth. Could such a place really exist? Scientists ponder this question, examining data from distant stars, searching for signs of planets that might harbor oceans beneath their surfaces. What secrets might it hold? The depths of its oceans could be teeming with life, strange and wondrous creatures that have adapted to the extreme conditions of their environment. In the movie, astronauts travel through a wormhole, a shortcut through space-time. This theoretical passage allows them to traverse vast distances in the blink of an eye, opening up new realms of exploration, their mission to find a new home for humanity. They embark on a journey fraught with danger and uncertainty, driven by the hope of securing a future for the human race. Miller's planet, with its promise of liquid water, becomes a prime target. The presence of water suggests the potential for life, making it a beacon of hope in the vastness of space. But as with all things in space, appearances can be deceiving. The universe is full of surprises, and what seems like a paradise could turn out to be a perilous trap. The quest for knowledge and survival continues as we navigate the oceans between the stars. Miller's planet exists in a constant state of flux. This is due to its proximity to Gargantua, the supermassive black hole at the center of its system. Gargantua's immense gravitational pull creates extreme tidal forces on the planet. These forces cause the planet's most distinctive feature, gigantic waves that circle the globe. The waves are not caused by wind, but by the black hole's pull on the planet's oceans. One of the most intriguing aspects of Miller's planet is its time dilation. This concept, while complex, is a cornerstone of the film's narrative and adds a layer of scientific authenticity that captivates the audience. Time dilation is a real phenomenon predicted by Einstein's theory of relativity. According to Einstein, time is not a constant. It can stretch and compress depending on the gravitational forces at play. This idea revolutionized our understanding of the universe. It means that time passes at different rates depending on the strength of the gravitational field. In regions with stronger gravitational fields, time moves more slowly. This is not just a theoretical concept, but has been confirmed through various experiments and observations. On Miller's planet, the gravitational pull of Gargantua is so strong that time is significantly slowed down. The planet orbits dangerously close to this massive black hole, creating an extreme time dilation effect that is both fascinating and perilous for the characters. 1 hour on the surface is equivalent to 7 years back on Earth. This stark difference in the passage of time creates a sense of urgency and tension, as every moment spent on Miller's planet translates to years lost on Earth. This time, difference becomes a major plot point in the film. The characters must navigate the challenges posed by this phenomenon, making critical decisions that impact their mission and their lives. The portrayal of time dilation in the film not only serves as a dramatic device, but also invites viewers to ponder the nature of time itself. The film's depiction of time dilation is a testament to the power of science fiction to explore complex scientific ideas in an accessible and engaging way. It challenges us to think about our place in the universe and the forces that shape our reality. Ultimately, the story of Miller's planet and its time dilation effect is a reminder of the intricate and often mysterious nature of the cosmos. It underscores the importance of scientific inquiry and the endless possibilities that lie beyond our current understanding. Imagine a wall of water taller than any skyscraper rushing towards you. This is the reality on Miller's planet. The immense tidal waves are a constant threat to any visitor. The astronauts, in their search for answers, must race against both the waves and time itself. Every second spent on the planet's surface means years lost back home. Despite its dangers, Miller's planet is also incredibly beautiful. The film portrays it as a world of endless oceans, with swirling clouds reflecting in the water's surface. The sheer scale of the waves, while terrifying, is also awe-inspiring. It's a reminder of the power and beauty of the universe, even in its most extreme forms. Section 6. A glimpse of what could be. Miller's planet, though fictional, raises intriguing questions about the universe. It makes us wonder about the vast expanse of space and the countless worlds that might exist beyond our reach. What secrets do these distant planets hold? Are there other worlds with conditions similar to Earth, or perhaps even more extraordinary? Could there be other planets like it out there? Scientists are constantly on the lookout, using advanced telescopes and spacecraft to hunt for new planets. Each discovery brings us closer to understanding our place in the cosmos. The search for exoplanets is not just about finding new worlds, but also about understanding the potential for life beyond our solar system. Planets orbiting black holes shaped by forces we can barely comprehend. These extreme environments challenge our understanding of physics and the nature of reality itself. The immense gravitational forces at play create phenomena that are both fascinating and terrifying. Could life exist in such harsh conditions, or are these planets destined to remain barren and lifeless? The movie doesn't give us all the answers, but it does spark our curiosity. It encourages us to ask questions and seek out knowledge. The portrayal of these distant worlds and the challenges faced by explorers inspire us to look up at the night sky with a sense of wonder and possibility. What if we could one day visit these planets ourselves? It reminds us that there's still so much we don't know about the universe and the wonders it may hold. The vastness of space is a constant reminder of our smallness, yet it also fuels our desire to explore and discover. Each new piece of information, each new discovery adds to the tapestry of knowledge that humanity has been weaving for centuries. The journey of exploration is far from over, and the possibilities are endless. Section 7. The science of Miller's planet, fact or fiction. While Miller's planet is a product of science fiction, it's grounded in real scientific concepts. Time dilation, black holes, and extreme tidal forces are all real phenomena. The film exaggerates some aspects for dramatic effect, but the underlying science adds a layer of plausibility to the story. It makes us wonder, what if? Section 8. The allure of the unknown. Miller's planet, with its alien beauty and scientific mysteries, embodies our fascination with the unknown. It represents the uncharted territories of space, waiting to be explored. The film, through its stunning visuals and thought-provoking story, encourages us to look up at the stars and wonder what might be out there. Section 9. Join the exploration. Want to delve deeper into the mysteries of space? Don't just wonder, discover. Subscribe now for more explorations into the cosmos, from the wonders of our own solar system to the mind-bending possibilities of black holes and beyond. The universe awaits.